All right, FRQ number 12 is about a dart player, and his chance of hitting the bullseye is 70% chance on any throw, and it says assume each throw is independent. So in part A, suppose Pete throws darts until he hits his first bullseye. So keyword hits his first bullseye. Find the probability the first bullseye occurs on the third throw. So that means I want to find the probability, I'm just going to call it X, is equal to 3. Now, how do you find that probability? You have to think, well, I'm guessing it's either geometric or binomial because the 70% chance is most likely our probability of success. It is our probability of success. And this one's geometric because it's happening on the third throw. And something, I didn't really take points off too much, but you really should have checked bits here. So the B, and I actually wrote it out. I'm writing with my finger, so I'm not going to write it out. But the B stands for binary, so you have to say there are two outcomes. He's either going to hit the bullseye or miss. We're told the throws are independent. The T is for trials. That's we're interested in making his first success on the third trial. And then S is for the probability of success is the same. We're told that any throw, he has a 70% chance of hitting it. So that's me saying, I know this is geometric. So you would go to your calculator, do a geom CDF, type in the correct parameters. I think it asks you for P and success, or P and then X. And I think almost everybody got this. You should have got 0.063. Meaning about this situation, he's gonna, the probability of him hitting his first bullseye on the third throw is 0.63. Some of you use the formula, which is nifty. Let me just show you that way. If he hits it on the third, that means he misses it the first two. So that's 0.3 times 0.3, or 0.3 squared. And then the next third throw, he hits it. There's your 0.7. So if you do 0.3 times 0.3 or 0.3 squared times 0.7, you get that same probability. B, what's the probability he hits 5 or fewer of his next 10 shots? Well, now this switches to binomial because there's a fixed number. No need to recheck the I and the S. Here you would just say this is now binomial because there's a fixed number of trials, and that's 10. So 5 or fewer, that means we're finding what's the probability X is less than or equal to 5. So you would do a binom CDF. Oh, this should have been PDF in part A as well. It's my bad. It's a PDF, geom PDF in part A. And B, though, it's a binom CDF. And then you type in the parameters that asked you, and I think everyone got this. It's 0.150. Meaning he has a 15% chance of hitting the bullseye 5 or less times. And that ties in with part C. So part C, Pete forgets his glasses one evening. He's confident he's just as accurate without them. On his first 10 shots of the night, he hits the bullseye only 5 times. So some of you did a binom PDF with 5, and that's fine. You end up with the same conclusion. We want to know, is that evidence that his glasses are important? I'm going to go based off of this part B answer. 15% of the time, and you need to write this in words. Again, I'm writing with my fingers, so I'm just going to say most of it. So without his glasses, or even with his glasses, the probability that he hits 5 or fewer of his next 10 shots is 15%. That's pretty likely. If you remember some of my previous videos, unlikely is really 5% or less, or really unlikely is usually 2.5% or less. So 15% isn't that unusual. So here you would have to say no, his glasses aren't important, because even with them, he could miss 5 or fewer 15% of the time. If you did the binom PDF with only 5, I think it ends up being like 0.103, something like that. You still get that same conclusion that that's still not that unusual for that result to happen.